Each year, Microsoft Research hosts hundreds of influential speakers from around the world, including leading scientists, renowned experts in technology, book authors, and leading academics, and makes videos of these lectures freely available.
Hello everyone and welcome to this session. It's a real honor to have Professor James Handler here with us today. I'm going to read his bio. I want to take the time. So he's the Tetherless World Chair of Computer and Cognitive Science at the Rensselaer Polytechnic Institute. He's also the Associate Director of the Web Science Research Initiative, which is headquarters at MIT. He was a recipient of a 1995 Fulbright Foundation Fellowship, a former member of the U.S. Air Force Science Advisory Board, and also a fellow of the very prestigious American Association for Artificial Intelligence and also the British Computer Society. He was also the former chief scientist of DARPA, the U.S. Defense Advanced Research Project agencies. And he's today also the editor-in-chief of IEEE Intelligent Systems and the first computer scientist to serve on the board of reviewing editors for science. Last but not least, he's also one of the inventors of the Semantic Web. And today he's going to talk about the Semantic Web, Web 3.0, linked data. Please welcome me in having here Professor Jim Handler. Thank you.
Thanks a lot. It's a pleasure to be here. Taken a number of years to be invited to give this talk in this forum, so it's nice to see that some of this stuff is starting to really hit, and that's a little bit of what my talk is about. I was going to actually subtitle this talk, The Buzzwords That Rule My Life, because I really spend a lot of my time trying to explain sort of the relations between these different things, what's new, what's different, is this just the old AI stuff? And this talk has been evolving for a while from sort of a talk about specific technologies, particularly ontologies for the web, to just more generally what's going on in this space to help people kind of plot what they're doing, what other people are doing, what some of the excitement's about, help you understand when you read a newspaper story that says some, semantic search company was bought by some very large software company for $100 million, what that implies, that kind of thing. So I'm going to start from ontologies for various reasons. This is a term that's been used a lot, and it's really the thing that's probably the most controversial or confusing part of this whole semantic web story, because the term has a long historic history. This term ontology is actually named after a Greek philosopher, and has been around for a few thousand years. And the couple thousand years. The original definition, sort of brought to computers, is provide a definitive and exhaustive classification of entities in all spheres of being. That's a Barry Smith quote. Barry's university, one of the New York universities, I should know, Buffalo. And it's a particular view of ontology that's kind of led to this model of very formal things, very expressive. I mean, again, if you want to do that, there's a couple of interesting things there. One is this notion of getting it right, that there's some kind of ground truth. So if we say there are physical objects and non-physical objects, that seems to be true of the outside world. But sort of those things can get very contentious very quickly, very hard to get content agreement. Sometimes the lower level terms are harder to get agreement on than the high level, sometimes the other way around. A different view, usually attributed to Gruber, is ontology is sort of an abstract, simplified view of the world that we wish to represent for some purpose. And what's interesting is this is not his most used quote. There's another definition that has more buzzwords and sounds more mystical. And what people have to a large degree forgotten is that part at the end about for some purpose. So that's really, in a certain sense, what the talk is about today. I want to look at some emerging models and ongoing work, and some of the challenge that bringing this kind of technology to the web does. But I want to bring it from a very pragmatic viewpoint. I have a wonderful quote I found in a Graham Hurst article, where Graham said, "The solution to any AI problem may be found in the writings of Wittgenstein, though the details of the implementation are sometimes rather sketchy." And of course, we as computer scientists and related fields, that's the thing we care about, is making something work. So this talk is really an implementation details talk, although I'm not going to drive down into details of the languages, details of the models, things like that. I want to sort of stay at the 50,000 foot level, as they say in the DoD, the view of abstraction where what's going on that's new and different without really getting down to the level of detail. But I'm happy to both be interrupted with questions, and I'll leave plenty of time after if you have those kind of questions. I'm happy to do it. I mean, I normally teach this stuff in a term-long course, and I've sort of shrunk it into an hour talk. A lot of stuff is on the cutting room floor. To put it into a historic context, a lot of the current talk about the semantic web dates from an article, Scientific American, March 2001, called The Semantic Web, which was written by Tim Berners-Lee, myself, and Aura Lassila, and has now become sort of one of the standard citations in the field. And this is the actual table of contents we sent to Scientific American when they asked us what the article would be about. So the letters are it's sort of who was going to write what. So we were standing in front of a whiteboard in Tim's office, and we sort of knew what we were building now and what worked, and we kind of knew what we thought would be really cool if this stuff was really out there. And we kind of had this blank in the middle, and we were talking about all sorts of transition models, and Tim just walks up to the board and writes, "Then a miracle occurs," which is an attribution to this famous cartoon where you see the two scientists, and one is saying to the other, "I think you should be more explicit here in step 2. But what Tim said is, if we get the design right, if we pay attention to the web stuff, this thing will scale, this thing will grow, and that the important thing is to build on the model that worked for the web, not to build on the models that didn't work for many, many parts of AI in the past." And so that's, again, a tension I want to sort of visit in this talk. The other thing I want to show is, in a certain sense, the miracle is happening. That last time I gave this talk, I spent so long on this slide, I didn't have time for much else. So I'm going to not really talk to it very much right now, except to mention a couple real quick things. So one is, a lot of companies are growing in this space, including now large companies getting second round financing. You've had a couple of big acquisitions like the PowerSet acquisition in the semantic search space, but that's an area where dozens and dozens of companies are playing in that space, a lot of startups in stealth. And then this thing called Web 3.0 is a growing new buzzword, which I'll visit again. But companies like Garlic in the UK, MetaWeb and Radar Networks in the US. Anyone who has a Twine account knows about Radar Networks. Juiced, Talus. Juiced is an online television. Talus is a company that's been doing database support for many years, is now doing RDF data hosting for some of these other companies and for certain other large companies. The other thing that's happened over the past couple of years is you've had a lot more, you've had almost the accelerating avalanche of larger players getting involved. So in about 2004, 2005, we could point sort of Adobe as putting this stuff in PDF documents, and Oracle was starting to think about it. Now it's supported in the Oracle suite. IBM has both open source tools and has announced that they will be announcing a support in DBase, although they haven't said what it is yet. Drug companies like Pfizer and Eli Lilly have given large presentations at BioIT. So a lot has been going on. Your own company has actually got some stuff happening in this space. I'll mention some of that later. So tools are starting. Several verticals have really driven this, but it's getting beyond those verticals now, which is part of what's exciting. And there's a lot in open source. So one of the things that's nice now is if you want to play with this stuff, it's not take a lot of courses and build a lot of stuff from scratch. It's download some stuff, fool around with it, hack up something, and start playing. And that's really been an exciting difference. Nowadays when I teach an undergraduate course on this stuff, the 3-week projects students do at the end of the term far exceed anything that was commercially available in 03 or 04. One of the things that's been happening in this space, and it's not the one I'm going to talk the most about, is the whole notion of lexical semantics getting excited. So one of the things that was going to power the Web 2.0 revolution was tagging, tag spaces, which still is happening and is very important. But there was this claim that somehow that was going to put the vocabulary development and ontology people out of business because communities would just generate their own tags and their own hierarchies. And the answer is that really turned out not to be the case. There's not a scalable technology there only from the tags. I mean, there's still a lot you can get out of them, but you need social context also, which I'm going to talk about later. But what started to happen is things like WordNet, things that have been learned ontologies, a lot of things like the stuff that's in MetaWeb. So PowerSet, for example, takes advantage of everything they can get their hands on, both natural language technology and semantic categorizations, and does things. There's some people who have matchmaking engines doing the same kind of thing. So some companies that are trying to figure out, does this profile match this profile, or using just categorization, hierarchies, things like that, and realize that now it's easy to find online readable large-scale versions of those instead of building your own or learning them from corpora. So some of that's happening. And of course, that works very well for certain things. It doesn't work so well for others. So there's a whole litany of traditional natural language projects, problems that we fight all the time when we do these lexical problems. But the other thing that sort of became evident in about the year 2000 and has been really taking off since then is that non-linguistic resources are a growing percentage of the web. And here I just simply mean things where either there aren't words or the words aren't the primary thing in it. So YouTube videos have some words attached to them, but by and large, you can't do a very good search in YouTube, even if you know what you're looking for. So you're looking for a particular performer's version of a particular song at a particular concert. You'll still get 8 pages of hits on YouTube, a lot of which are some kid with a guitar imitating that guy at the thing, or someone who says, I was at the concert and this thing happened over here. So again, a lot of the imprecision, partly because there's a lot less words. So Flickr tagging the idea was that you'd be able to do clustering of the Flickr tags. That would give you nice hierarchical structures. Turned out Flickr put that on and then took it off a few months later because it was doing so poorly, right? So for a short time, you would do Turkey and you'd get birds and you'd get the country and you'd get a couple other things. And then they started getting confusion. Well, why? Well, because they had 1 million documents, each with 4 words on it. Ask an IR person how easy that is to do good precision on. So more stuff was needed. And then the other big thing, of course, is any kind of structured or semi-structured data that's not primarily linguistic. The number 14 in a database can be an age, can be a lot of other things. So you can't just say, do me a search in the database for the number 14 as a meaningful thing. You have to know what the columns, rows, meanings, et cetera are. Again, if you're trying to do that across databases, if you're trying to get data interoperability, so sort of from the web scale, XML for data transfer has been very, very successful. XML for data integration, search, et cetera, has been much less successful on its own. So again, a lot of this stuff has been going on. The traditional AI approach to this stuff was, well, if you can't do the words, you need sort of knowledge about the stuff. So this is the field of knowledge representation, has been a mainstay of AI since very early on. You can talk about formal things like, so a student is a person. So in this view, the ontology is just this set of rules and all of the entailments from those rules. So if I say X is a student, And if I say a student is a person and a person is a mammal, then we're entitled to know X is a mammal. Okay? It's often been, it's still a mainstay of AI. There's still big KR conferences and things. But it was rightly criticized for many years, complexity, undecidability issues, definitional adequacy, knowledge engineering, grounding. I mean, there's a whole literature. So just like some of these other things, right, there's still a lot of research in that space alone. But what's been happening is that stuff has been seeing a new life on the web. Some of this was motivated by the web ontology language OWL, but what I want to show you is that there's kind of a different way it's been gaining life, and that there's really these different things happening that even though they're using the same substrate are using it in very different ways, and some of it is very different than what we've seen in the past because of the web's involvement. So I think in this, the main thing I want to point out is, so there was this language that can be viewed a couple of different ways. So it was, when it was created, there was a tension between the people from the AI community who wanted a knowledge representation language and the people from the web community who wanted a language that would be useful on the web for data integration and other such things. So it was created by a committee, and like most things created by a committee, it has good and bad features, and depending who you are, you have different opinions about which are which. But what's interesting is, by many orders of magnitude, it's the most used knowledge representation language in history. Depending how you ask, Google can find you thousands to tens of thousands of these, of documents that are just definitions of domains in OWL, and there's many more of them behind firewalls and things like that. And this is just an example. If you Google for student, looking only in files that end with OWL, you get about 400 or 500 of them. And you know, the top ones to the bottom ones, the ranking doesn't work very well because, of course, these are just being ranked as if they're text documents, but they don't have that same pointer space, things like that. So there's a lot of interesting issues. But what you can see is there's a lot of stuff out there. Even down into the 20th or 30th page, we're still seeing documents that are people defining something called a student. Okay, so this stuff has really started to be out there, but the question is how it's used. And what we've seen is very different kinds of use cases emerging. One is sort of what I would call much more like the traditional AI use case. So the U.S. National Center for Biotechnology has what they call the oncology metathesaurus, or everyone in the world calls the cancer ontology. Is maintained full-time, has about 50,000 plus classes, updated monthly. And if you get funding from the NIH to do cancer research, basically you have to use this as your keyword taxonomy, but it's actually more complex than a keyword taxonomy. It has many subsections. So if you're doing a clinical trial on the use of some chemical to prevent a certain kind of cancer in a certain kind of organism, you have to sort of categorize it against those things. It rigorously follows what's called the OWL-DL model, which is the decidable subset of OWL. It's provably consistent, which is one of the reasons it takes so many people. So anyone makes a change, everyone else has to make sure that change gets done. And I'm going to contrast that with another ontology called Friend of a Friend. Friend of a Friend is sort of an open social networking thing. It was built by a couple people in England, Dan Brickley and Libby Miller. So, you know, I mean, this one, you can't even talk about who built it. Here we actually, you know, can say Dan and Libby did it. It's maintained by consensus in a small community of developers. It violates all the rules of this decidable stuff. It's used very inconsistently, so different organizations describing their people have a tendency, some of them sort of store email addresses, some of them store an encoding of email addresses, things like that. The interesting thing about it is that the NCBI ontology does have high use in a very specialized community. It has a very high cost for what it does. There's very little data on the web that's indexed against that, so it's growing. FOAF has about 60 million entities that are known to it. So there are these files out there and that says, you know, this is a FOAF thing and it has this name and this property and things like that. Not necessarily distinct individuals, in fact, necessarily not distinct individuals. A lot of these are created by different organizations, and what they're publishing the FOAF for is to allow people to link things across that. It's used by a large number of providers, so sometimes I ask people, do they have a FOAF file? And very few people in the audience raise their hand, and I say, do you use LiveJournal? Have you ever published anything in Flickr, Tribe, Juiced? A lot of these things actually create for you some kind of FOAF file. And many of the social networking sites, because this is catching on, will now make it exportable. So if you have a Facebook profile and want to play in the FOAF world, there's a little program you can run, and it'll export you and your friends and all that stuff in a FOAF-compatible way. So it's sort of becoming a de facto standard for open social networking. So the interesting thing about it is we have the first ontology, which by every standard of the traditional, kind of knowledge representation and knowledge engineering approach is the Cadillac of this. I mean, beautiful, well-maintained, heavily cared for, versus this FOAF thing, which is small, scruffy, and being used more than any other ontology in history, again, by orders of magnitude. So it's kind of the what's happening there that I want to drill down on a little bit. So one of the things that's been happening on the web is a view of OWL as a formal KR standard. And in fact, one of the things that happened is OWL grew out of a DARPA program called the DARPA Agent Markup Language, joined with a European group called OIL, which actually had 3 or 4 different acronyms depending whose paper you read. So it was the OWL, it was the ontology integration level, the ontology integration layer, and various other things. DARPA stopped funding it, or pretty much let the original program run out and didn't create any follow-up funding. So almost all the funding moved to Europe. And for the first couple years of European funding under Framework 5 and Framework 6, a lot of the work was for formal work in ontology development and ontology. So it was really the old AI stuff in the new guise. So a lot of effort went in, and so there was this thing that went out that what OWL is a KR language, and that's where a lot of the government funding was, and since most of the work going on was within universities, that was kind of where the focus of attention was. And that actually had some neat advantages. So for example, in about 2000, so when the DAML program was starting, the description logic community claimed to have sort of the most scalable knowledge rep stuff that anyone had done that actually had a formal logic basis, et cetera, et cetera, et cetera. And if you actually looked out and found the papers, you could find that the best performance result was 10,000 axioms, took about a day to get classified. Okay, if you look now, because again, there's a commercial interest in this stuff, you're seeing something like 50 million axioms with 1 million facts taking 10 or 15 minutes. So it's very different kind of performance scale time, and not just computers getting faster. A lot of research effort went into it. Again, a lot of that from the European Union, and also a lot of moving to parallelism as a scaling mechanism has been being looked at now. So more web server back-end kind of parallelism. So I got 100 machine server farm. How can I distribute some of this stuff? It turns out not to distribute very well. So a lot of people are thinking about how you could do that differently. And there's actually some efforts going on now to look at much larger data sets against these ontologies. IBM has something called SURE. Oracle has something called OWL Prime. So again, this view is OWL as a KR language. I give a talk called The Two Towers, and this is the tower I use to portray this work. It's extremely powerful stuff. It's sort of like Sauron's tower in Lord of the Rings, where you got to keep a lot of orcs around the outside, because all it took was one hobbit sneaking in to make the whole thing come by. And of course here, this thing has a decidable logic basis. The biggest advantage of this kind of reasoning is it's sound and complete. You get all and only the correct answers. And if you use this particular set of restrictions, it's a decidable problem. Now, it may still take a very long time, but at least provably there is a correctness to this thing, which of course makes researchers very happy. I think I'm not going to talk much about this except to say, again, so this was a thesis written about a couple years ago by one of my students, was given a large one of these things, there'd been things that could prove them inconsistent, but they couldn't actually tell you why. So a good doctoral thesis was he took he built something that was a reasonably scalable algorithm for something with a couple thousand classes for explaining what were the set of inferences that caused a problem. Right, so that was again, a thesis level problem in this stuff. So this stuff is things where, again, the inconsistency makes the thing almost unusable. I'm lying in one sense, which is that many of these models have some kind of way of having a modeled inconsistency. So the psych language, which is more powerful than this, has a notion they call microcontext, and in psych you can know that Sherlock Holmes, in the Sherlock Holmes universe, Sherlock Holmes is a real person, and in the non-Sherlock, in our universe, he's a fictional person, right? But it's still a very controlled model. You can't just sort of throw an arbitrary fact into psych and if it doesn't get into the right place, it can cause all sorts of heck. So if I say Sherlock Holmes did something and forget to say, by the way, I'm talking in the Sherlock Holmes universe, then I have implied that a fictional character can do certain things that a fictional character can't do, and I get inconsistency and problems and all that sort of stuff. But there's a fairly compelling argument for these kind of systems. This is sort of the old AI knowledge expert kind of argument on the web. So here's, looking for proteins using various kinds of image searches and things. Here's using a semantic web portal that Fujitsu is playing with, and there's now one of these being supported within several of the large drug companies. So it's pulling together, it's integrating a lot of information about things coming from different sources and putting them into kind of a web framework. So you can see the particular protein, the various different ways of looking at its sequencing information, things like that. And again, if you're doing professional work with these kind of things, there's a fairly compelling reason. I want my doctor to know about this kind of information, not this kind of information. Okay? And where this stuff has really seen its return on investment has been what's new from the traditional AI point of view is traditional AI pretty much looked at these ontologies without paying too much attention to the data. And where this stuff has been is it's now scaled to the point where within a controlled enterprise framework, so where you own the vocabulary and where you own the data and where you can do the registration between those things carefully, cleanly, you can clean up the data, things like that. You can do some very exciting things in here. So drug discovery was one of the early published successes. You build an ontology with very, as expressively as possible that a thing that has this property and this property and this property can be in this class but not in this class. And then what you can do is take results from something like combinatorial chemistry where you're getting, somebody once told me that they can now generate in an hour what it takes a single human a year to process. Okay, and they've got the thing running 24/7, right? So sort of each day they're getting 24 years behind if you only had a single person, and they need machine help in this. And here what they can do is grab a bunch of that stuff, throw it against the model, looking for a particular category or class that's needed for some drug thing. And in this kind of ROI, the thing you're building is very, very expensive, but what's nice is that bad or missed answers are money down the drain, right? So if you didn't get some part of your assay that could have been the thing that was the aerobic, anaerobic, hydrophilic, something or other, you've missed your chance to get the next big drug out the door. On the other hand, if you find too many wrong, lots of false negatives, then each one you have to test can cost a lot of money. So modeling is very expensive, and the return on the investment must be very high. Okay? Problem is that's exactly why the old expert system revolution in AI never really came to fruition the way it was expected, because there aren't that many problems in the real world where there is that much money and you need that return. You get that kind of return, right? There are lots of them, but it's not nearly as much as the long tail of problems that generate, a little bit or have a very different flavor to them or have a very different feel to them. And a lot of data integration in the wild, or large-scale data integration, goes beyond the needs of control in a single vocabulary. So there's an alternate view that's been growing over the past couple years, and this is really the one that powers this Web 3.0 idea, which is that OWL was based on RDF, which was a model to bring it to the semantic web. And in fact, there's a new standards group building the new version of OWL who are trying desperately to pull it out of RDF and get it into XML. The good news is too many of the users have said no. Because it was built with various web architecture things in mind, but more importantly, it was built with the web culture in mind, which is very different than the mindset of that other kind of model. This is a open and extensible model. You don't like my ontology? Fine. Build your own, or extend it, or change it, or do something, or find someone else's to use, right? That wasn't the traditional knowledge. That's not the traditional engineering approach. That's the traditional sort of software hacking approach, right? Get some stuff, make it work, play with it, share it, publish it. It also has a nice feature from the web application development point of view because it scales in a sort of database-y way, which I'll talk about in a minute. So things can link to each other. Things can create link spaces. Things can be pulled out and stored in various kind of repositories and things. And so there's some ways of linking to the formal model, but what we're really seeing is a heavy use of a very small part of OWL. So you have a lot of data and a little bit of semantics. And OWL has this model theory, the exact legitimized inferences that if you want to build a compliant OWL reasoner, it must have all and only these entailments, right? A lot of the guys building these triple stores and inferencing over that sort of say, oh, OWL has this thing called same as. I need a thing called same as. Great, we'll just, use same as, right? And they couldn't read the model theory if they wanted. I can't read the model theory, and I got a PhD in this stuff. I chaired the working group that produced it. But so there's a lot of interesting things going on, and there's some really interesting debates in the community about these things. But what's nice is the web application community doesn't listen to these debates. They find something useful, they build with it. So that's really what started to happen was a data web approach, which said people wanted to share data on the web. Data sort of shares better in these graph models. RDF matches these graph models nicely to the web. And what the real motivation that's pushing people now is, you hear people talking about, well, is this going to put Google out of business? Well, that's not really what people are trying to do. What people want to be is the next Google thing, right? So for the original web, there were some big winners, right? For the Web 2.0, there were some big winners. There's now this other thing happening on the web, and people want to be the big winner. So if you go to a conference on the West Coast, down in the San Francisco area, you will see that community starting to get very excited by this stuff. A couple of the companies I mentioned before, the Web 3.0 companies, Radar, MetaWeb, have gotten their second round funding. Of course, some excitement was generated by the PowerSet buyout, things like that. So a lot of excitement in this space right now. And given what the economy looks like right now, for something to be hot in the venture area means something must be going on there. And here's something going on at sort of a more technical level that I'm not going to go into too much detail about. But anyone who knows really how web apps work know that you start by, you have a browser or a web application. It does a request back to some kind of dynamic content engine. Dynamic content engine works with a database, pulls up something which is then sent back as HTML, which is then displayed in your browser or XML or whatever. Okay? So essentially, a lot of the text documents we talk about on the web as text documents aren't really text documents. They're really textual representation of something in a database. And when you do mashups, a lot of what you try to do is then mine out of that HTML what the data looked like so you can put it together with some other data. Okay, well, as this notion of fast, quick mashup tools, ways to put things together, some people playing with RDF started to realize that the triple store looks just like a database. The Sparkle language lets you do a SQL-like query against that kind of database. And what you get back can be turned both into traditional presentation, but also into something that can be stuck into another triple store. Again, you have to go read the specs if you want to see the details. But that's exciting because now this triple store can have its own web app. So my web app can simultaneously be the dynamic content engine for my application and a service provider for another application. And you can kind of get this fractal nature of that. So people started recognizing that, and it's now been used in a lot of different sites. This is actually, so as I was doing this talk today, right after I had done the save, I got email which had the announcement of the first Web 3.0 conference expo. And interestingly enough, I already had titled my slide before I saw this thing called Linked Data, Semantic Web, Web 3.0. So you can see this is a meme that's starting to get out there. Will this be as big as the Web 2.0 conference? Not this year. Will it be in 5 years? It'll be bigger. That's what people are betting on. I mean, sorry, that's not a statement of fact. People are betting on this one's on this curve and the other one is on the leveling out. Why? Again, because the big one is still out there. If you don't believe me, right, believe the world's largest software company, which said that there's a real reason why you should use RDF databases, which is that basically it gives you a data store in a very flexible schema that later can be added to. So one of the problems you have in a database is you have to get you got to get your data representation right the first time, because once you've deployed the application, if you want to add 2 new columns, that's a non-trivial thing. Whereas in some of these other things, you could just say, well, I'll just add some properties and attach it to those things that have them, and we'll just keep going and then, you know, kind of do it. So there are trade-offs. It's sort of easier to get stuff in some ways harder to get stuff out. Second one is it helps you to create web-like relationships between data, which is not easily done in a typical relational database. This was actually published in one of the .NET documents back in December 06. If you go to it today, you won't actually find this quote. You'll find a pointer to a discussion about Sparkle, which has come out since then, which is now the data standard for querying RDF data. So there's Sparkle support deep in there for doing certain things which are just very hard to do in relational data. So again, the web community, the developer community, didn't really care about AI's religion or about things like that. They said, hey, we got some stuff that matches very neatly to this kind of problem. And that really became the driver. Well, so just as an example, here's a company that's been doing a lot of stuff with this. Dave Beckett, who works at Yahoo, gave a talk at Semantic Technologies 08. The slides are there. If you don't believe me about this stuff, his slides actually tell the story better and at a technical level from a web developer viewpoint. But these are some of the Yahoo sites that now use this stuff. It's not completely RDF. It's the RDF being used to enhance a traditional website. Food, travel, finance, lifestyles. Again, they're using some of this semantic stuff to link them to other databases, or like in the foods things, recipes are very hard to store in a traditional database. How many steps, how many things, how do you do it, right? So typically what happens is they're stored in a traditional databases, a few fields of metadata, and then the whole recipe in text, right? In RDF, there was kind of a model where you could say, it has steps, and the steps of these things, and things like that. It's not that you can't morph one into the other. It's just it was a more natural fit. And they were pulling these recipes from many different sites. So again, it was just that mashup story I was talking before. They needed to get from data to data. They were all their own sites. So they built this Sparkle way of doing it and then merged the stuff, which gives them some better control over what they get. So again, it's just a different use of an applied technology. But you know, sort of, is this stuff real? Well, these are websites that are real websites with very high hits and live in the real world. The question I was asked most by the AI community is, but you know, how can you live without this soundness and completeness? How do these guys get along with such a scruffy thing? Answer is, for a lot of applications, that's not your goal. Okay, this is Twine. Twine is Radar Networks' attempt to be the big one in Web 3.0. Nova Spivak's company. It's basically social networking, but with the ability to share entities and a lot of metadata extraction happening automatically to make the entity sharing, storage, search, presentation happen better and a lot of ideas for the future about how vocabularies can play into this. I'm on the advisory board, so I can't talk too much about the details. But let's look at this example, right? They're recommending to me some people who I might want to be a friend with in this thing, okay? And here's the list of people. Well, I actually know a couple of these people. This one is someone named Tricia who describes herself as an arbiter of style from San Francisco, California. Now, this, of course, you look at me, that doesn't strike you as the necessary best recommendation, right? So guess which one I clicked on, right? Well, I clicked on Tricia and discovered a lot of common friends, a lot of common interests. Said, hey, this thing recommended, we should join. We now actually share a fair number of things, sending it back and forth. So she's made me aware of some stuff I didn't know existed, like style. And I help her with some of the technology stuff from Semantic Web. We've never actually met in person. I have no idea if it's a he, a she, or what. But again, it's or if she has style. More than I do, I can tell you that no matter what. Anyway, key point is, think Google, right? Google's job is not to get you all the right documents, right? It's get some good one into that first page, right? It doesn't even have to get all the good ones into the first page. And a lot of things happening, Live Search does a lot of this now too, is trying to find, can I find a set of different ways? So if you Google for Hendler and I only show you the same guy for the first 500 hits, that's a bad idea. So how do I start recognizing different people, so again, some of the semantics is even coming into either latent or real in terms of just categorizing those first hits, because that's your job. So no one is ever actually going to look at the entire set of recommendations to see if they're sound and complete or care. In fact, some of the errors could be interesting, but it's got to be fast and it's got to work, right? If you had to wait 30 seconds for a Google page when Google first came out, they would not be the search company we all talk about trying to compete with, right? But there's a problem. So this is my second tower. So I portrayed that first view as Sauron's tower. The second view is more like the Tower of Babel, right? We're going to build this new web. It's going to be the web of data. Everything's going to link together. It's going to be this wonderful, wonderful Web 3.0 web. And who cares about these language issues? Who cares about common terminology or anything? We'll use a little bit of linguistics and it'll make the whole thing work. And when God wanted to make a tower fall down, if you believe the Bible, it said, you make the people talk different languages. You can't build together, right? In a certain sense, you can't get interoperability without agreement. You can get agreement in something like OWL or RDF on the syntactic form, but you still have all the content issues. So again, in the small or where there's a small amount of ontology over a very large set of data, you can solve that problem essentially by keeping things small and manageable by hand. But as things grow, there's a lot of issues. But one of the important things that has emerged on this semantic web frame is, I don't really want to go into this in too much detail, but RDF is built on top of URIs. URIs are very different than strings, right? Because if I say student, I could mean a lot of different things, both explicitly different. So, for example, if you go to Oxford and go to Christchurch College, student means faculty. So actually, student means a don. Okay, so one of the college dons. I don't actually know what they call I think it's a capital S student and a small s student. Small s students are the people who take the classes from the large S students. But it can also be just subtle differences, right? In some places, somebody taking a training course would be called a student, and in other places, only someone enrolled in a university might be called, things like that. But if I say, HTTP, www.cs.rpi, edu, Hendler, twgroup.owl #student, and you see two websites using that thing, seems very unlikely that they're doing it by accident. So seeing that they mean the same thing becomes easy. Of course, now if I'm using one of these to describe something and you're using a different one, we still have a mapping problem. But now we can put an assertion in there and say this is the same as that. Again, so we can build these things up as vocabularies across different vocabularies. Never allowed in the AI world. You had to bring it all into one place and get all the agreement, right? And that's actually turns out to be a big difference. And there's a lot of interesting things. So recognizing, asserting, and changing inequality. So it turns out the little bit of OWL that has proved to be used over and over again is essentially a class hierarchy and some property things, and the ability to say, for those of you who are database people, it's almost like an ER kind of model, right? One-to-one, one-to-many, many-to-one, subclass, class, inverse, transitive, symmetric. So a few vocabulary terms for properties, but the ability to say those things about different ones to get some kind of linking and merging. Turns out there's a lot of other things about URIs that are interesting in terms of, so one of the things someone once said is, boy, the web would be really easy to label if we only had an infinitely extensible labeling space that was dereferenceable. Well, we actually have one of those on the web. It's http:// and then all the rest of that stuff, right? You can always coin a new one of those, right? And there's some social conventions about who owns it, where it lives, what it does, and it happens to play nice with your browser, right? So you don't need a new technology infrastructure to go look at someone else's document here. You can just grab it by typing that URI and looking at the thing that comes back. So again, there were a lot of advantages to doing it this way. And so what's been happening now, this is one of several different projects in this kind of space. So this is where the linked data term is coming from. So this is a project called the Linked Open Data Cloud. There's some other things. But basically, you have a data set you'd like to share with the rest of the world. You publish it as RDF, and you provide mapping to some other thing in the cloud. And mapping is defined as expressing same as relationships or something, some property that lets the computer map those same as. So everybody who has the same email address will be considered same as. Okay? These are all things that are actually in the thing now. This is about a month old, so there's probably another half dozen bullets. It's got tens of billions of assertions. So to pull it all together into a single data store is hard. To mine it is hard. In fact, what to do with it is questionable. A lot of people are looking at browsers for this thing. So you start in something like the music one, and that'll get you into DBpedia, which is Wikipedia's kind of relationship model. And that'll get you to some places so you can sort of say, hey, I just noticed that this guy I'm looking at was born in this place, so that's interesting for whatever reason. One of my students did a project trying to mine just music brains in DBpedia to do things like say what music genres started in Seattle. I'm sorry, you needed music brains, DBpedia, and geonames, right? And it did as well as any other data mining thing done quickly. So 60, 70% interesting answers, a lot of bad answers. No real deep analysis. But it just shows that this thing is growing and lots of stuff. So if you want to start playing with this, right, getting a data asset is actually not the hard thing anymore. Right? You can go grab any part of this. It's all public. It's all out there. It's all in easily available standards. And there's open source and proprietary tools for viewing, playing, extending. So it's actually, happening. So again, this is So in a sense, this idea of Web 3.0 is this linked data cloud, that RDF and OWL story to provide these links. So the databases, the links that are created by OWL, same as, inverse functional, that kind of thing, and the sort of vocabulary space over it that helps you start linking these things up to other kinds of concepts. So that's sort of the model. Web 3.0. In the interest of time, I'm not going to go through the next set of slides very much. But another thing that turns out to really be showing up in this thing is Web 2.0 and Web 3.0 being used together. This sort of comes as, a dough experience for me. Sort of back in the old AI days, we kept realizing that AI really never did very much by itself. It had to be integrated with something else. And so here, too, social context is a very important part of a lot of what happens on the web now, and in these, you get the network effect from social context. One of the things that's happening, though, that's interesting is there are now some semantic web standards starting to be used by the library community to release some large thesauri. So the Getty catalog, I mentioned the NCBI catalog, Natural Library of Agriculture. A lot of these things are starting to release these ontologies. What's interesting about that is that gives you persistent URIs. So I can link stuff I'm doing to those, and other people can link things to those to build that web space I was talking about. So I don't actually have to say my cow is the same as her cow or use the same term if we've both said mine is the same as the one the National Library of Agriculture calls a cow. Right, so various things can happen. And by the way, that's also true, it turns out, for anything with persistent URI. So a lot of people are starting to link these things up to Wikipedia entries. So in the ontology world, there's this whole conference devoted to how shall we do commenting on classes and ontologies? What's the right level? On the semantic web, most of the people doing this started realizing just stick a link to the Wikipedia page or to the Flickr persistent URI that you mean. So if cat shows you 500 pictures of things with 4 legs that go meow, there's really no confusion about what kind of thing you're talking about, whether it's a tractor or an animal, for a human. I mean, so again, this is more human referencing. But of course, that starts to create a link space that says this term and this term have been linked to this thing in Wikipedia, so you also get this other kind of emerging thing happening. I have a paper about this for anyone who's interested, so I won't talk about it really quick. I'm just going to go quickly. But a lot of us are starting to believe that what's going on is Web 2 is really being powered less by the vocabulary space and more by the social context. That's not really too surprising. But what I mean by that is if you go to Flickr and type James, right, you will find over 1 million pictures that have the tag James on them. That's not very useful as a tag. Nobody, I suspect very few people other than me ever go to Flickr and type James as their keyword search, because I do it to see how many I get. What makes sense about James being used so often as a tag is that Flickr lets me go to your Flickr stuff, Bob's Flickr stuff, and Bob has a brother named James. So James suddenly becomes a useful term. Okay. In fact, if you go to a lot of conferences nowadays, you'll see somewhere on the conference page or somebody announce, let's use the following Flickr term when you upload pictures of this thing. So again, if you were in the social context where you could learn that term, or if you can guess it through some other context, then you can find those pictures. If not, it doesn't really have any semantic meaning for you. Okay. Web 3.0 is much more shared data and linked ontologies. So here, you're really seeing the network effect through the social network at scale now. And what you're seeing here is really the relationships through the vocabulary network and data network at scale. And it's putting those two together is starting to get a lot of people excited. I won't explain this in very much, but except to say, so one example that people are starting to play with a lot, it used to be called seeded tagging. Now people are referring to it as semantic gridding. But the idea is that I give you the ability to do tags, but I try hard to find a way to figure out what to get you to sort of register your tag against known terms. So you type POL about something, and I show you that Poland is a possible extension, and you click on that, right? Then I don't get POLNAD very often, right? Then I know that you chose, and I could have said countries Poland or something like that. So I kind of know the context you were in when you did that gridding. So I try to get the tags to a known vocabulary. Now, they still can be extended by lots of social stuff, but the minute I get some good tags to some things I know, then I can start doing some very powerful thing. A few different of these sites that did country-related things have now realized they all had different country vocabularies. They did the same as trick. Okay, so instead of building one single one and re-engineering, they built a set of mappings. And then what happens now is if you're on one of these pages, you see ads for the others, because it knows that you're looking at information about Poland on the travel site, and it says, want to see pictures, want to see blog entries, again, from other sites which have used that same kind of thing. So by gridding things to the right place, you can get these relationships. Instead of trying to guess from the text, you've sort of made it so people would tag the right places. Another example, there's been something floating around the semantic web space, actually from before the semantic web, called the wine agent. And the wine ontology, it sort of was a thing which would say, you want to have this food, here's a good recommendation of a wine. First version of it had all the wines in the knowledge base, all of the recommendations in the database. So if you wanted to get So a big community kind of got together and said, fish is served with white wine and it should be a light red, it should be a heavy sugar light wine, this region kind of thing. Needed to get a lot of community involvement, a lot of community agreement. And essentially this old agent would give you the right wine recommendation. If you disagreed, tough, right? You're wrong, right? That was kind of the old mindset. Well, some of us like different wines. So a more recent wine ontology, this is one developed at my group, so I'm actually showing you some of my own work for once. We added a recommendation kind of thing on top of it. So again, using some of this gridding kind of thing. So it still needs a lot of interface work, and part of the reason it looks bad there is it actually is made to run on iPhones and similar type devices, and so when you see it on a regular browser, it looks a little funny. But basically what would happen is, so if I clicked on one of these kinds of fish, what I'd see is, I skipped a step. I would now see something that says, here are the recommendations relating to that. And then I can say yes, yes, no, no to the ones I'm on. So roughly corresponding to, I'm going to dinner with Deb and Fred and Sam. I want to see Deb and Fred and Sam's preferences taken into account and not everybody else's. And then what it does is it goes through the old wine ontology, generates instead of now having the wines built in, it takes those wine properties, it does Sparkle queries to some wine databases that right now are being done by scraping wine sites. We're actually talking to some of the large wine stores in our area to have them keep their database, build them a little tool so their database will export the Sparkle for us, so it'll actually be up to date with their prices and things. But anyway, so this says, for example, this particular Chardonnay was a good recommendation, but you can actually see that of the people you picked, 9 of them kind of would agree with this recommendation, and 6 of them would have some problems with that recommendation, and these are kind of their preferences. Again, a lot of interface work needed. If I pick a different wine, so this is picking a red one, it's actually telling me really only this guy liked it, and there were a lot of people who didn't like it, but that kind of thing. So you can imagine someday being able to say, my killer app for this is, you're in a restaurant. Their menu is online, their wine list is online. You've got your social network, so you say, I'm with, this person, this person, this person. This person's having this dish, this person's having this, having this, and it'll come back and say, okay, here are the wines I recommend. And I say, that one's too expensive. How about this one? It says, that's good, although there's an even better one in that class if you're willing to make Fred less happy. That kind of thing. So again, that's a modern kind of webby way of thinking about this ontology. It's all still powered by ontology, reasoning, data linking, but again, we're not thinking about it anymore as the world of making everyone agree. We're thinking about it as the web world of people able to disagree. Now, by the way, I should mention for those of you who are former knowledge rep junkies, right, that red wine and white wine are disjoint classes. And so if somebody says they like red wine with fish, and someone else says they like white wine with fish, and you just stick it in the ontology as those are both the correct thing to have with fish, your whole thing becomes inconsistent and logic goes to hell. So either you could build a complex context mechanism for knowing it's Jim who likes red and so likes white. What we did is, again, we just built this on top, and because the inferencing is pretty quick, we just run through your friends, doing the inferencing for each one, get that set of things, and then do the thing. So again, we're mixing traditional reasoning with just more, kind of quick ad hoc procedural rule stuff. Web 3.0, I've been talking about it primarily in the web app domain. Let me quickly mention that it's also been used in a lot of other places. So interestingly, there's been this funny circle. So a lot of the domains that first got interested in the semantic web, particularly life science and health stuff, were because those domains actually already had a lot of stuff that was in the old AI formats, that they liked getting it to the web. So there were lots of so like the National Cancer Institute ontology wasn't built for OWL. It said, hey, great, OWL's a way we can share the ontology. Okay. But there was no reasoner other than the one that they had as their proprietary thing, which they had a whole company doing. They kept them in business so that they could get some reasoning done, mostly in their workflow for keeping the thing consistent. That went, sort of once it went to OWL, a bunch of people started trying out their tools on it, right? So there's now about a half dozen reasoners, which are typically test it against that ontology, which of course meant that a lot of other players in the medical domain said, hey, my ontology can do that too, and I don't have to build a company to keep it. I now got all these other players. Well, that put out a bunch of big vocabularies, which motivated some other people, particularly Oracle in the early days, to start building tool sets, which started supporting other things, which by the time in 2006, the Web 3.0 guys started to come around, now those tools were ready at a scale. So they kind of started playing with it. Well, now some of the original guys are saying, hey, we can do that web thing too, not just the AI thing. So in health science, e-science is an area you're seeing a lot of it. There was if you went to the summit, there was a lot of talk about Spacebook, My Experiment. VSO is the Virtual Solar Observatory. WTT actually doesn't use this stuff, but the group at Harvard that helped in that work is actually starting to use this to link in a bunch of paper stuff. We're starting to work with them. A lot of people have been looking at provenance and annotation for data because there are some semantic web ways of doing that. Group curation of domain ontology. So one of the things that's actually proved to be very interesting is as new guys come in and say, well, we want an ontology, but we don't have the $1 million that the Cancer Institute has. What's become sort of the methodology is take the data stuff you have, reverse engineer one of these sort of weaker ontologies from it, run that past some people in your community who say, that's stupid, this is good, that's stupid, this is good, fix it up in a sort of iterative process, and then put that one out there for the community to curate. And then have, among those curators, an AI person is sort of the gardener in the wiki sense of gardener. So you have one knowledge engineer, a bunch of scientists, and a science ontology that's now being maintained in a consistent way. That's proving to be used in several of these merged virtual things. So there's now several different virtual observatories for Sun, for standard space, things like that, starting to link up. A lot of smaller sciences are starting to do some of this stuff. A lot of stuff has fed back into the finance and business world. Two in particular that are interesting is RSS type feeds were originally done in RDF. Some of them moved out of it, now have moved back into it, using more of the OWL stuff in there. So against ontologies, meaning that the people getting it can do a faster and can do a good sorting. Of course, there's some performance issues there. There's been some new work on very rapid streaming versions of this kind of reasoning. So better feeds with fast domain reasoning, and then personnel finders using some of the match. So it turns out a lot of the semantic stuff has been used in a lot of the dating sites for a while, very quietly, because somebody says I play tennis and somebody else says I play squash. They want to give them some value of that being a match rather than, and if squash to scuba diving will be less so, right? But at least they're both sports, that kind of thing. So it turns out, so some people are now taking some of those kind of match engines, trying to bring them back into professional context. There's a company called Paradigm 5 that just recently went into an open beta that's doing some of that stuff. Interestingly, research challenges remain. This is one of my favorite ways of saying this. There's a big project in the EU called the Large Knowledge Collider, which has this slogan: current reasoning systems do not scale to the requirements of their hottest applications. So in a sense, that's what I've been talking about. There's also integrating of these things. There's a project going on in the Cleveland Clinic, which was kind of neat. There was funding going into the Psych project doing kind of deep semantic querying, and there was funding going into a group that was just trying to get all the questionnaires being filled out in all the different databases to come into a unified data format in RDF. And these guys were told, we'd like you to work together. And they said, no way, go away, leave us alone. And the guy said, no, maybe you didn't hear me. Neither of you get funded unless you work together. And they said, right, we said we'd love to do this. It was a marriage of convenience for the first 6 months or a year. Now it's actually showing some really neat results. So it's still a little bit of a marriage of convenience. This is the RDF guys gave me this slide, and if you look up in the corner here, it mentions Psych. And the Psych guys give me this slide, and if you notice down in the corner here, it mentions Sparkle. But they do link up. But more importantly, still big differences in the communities. But what's interesting is they're using this OWL representation, which these guys see as too powerful for what they normally do. And these guys see us too weak for what they normally do as a place to have the joint curation happening, because it's actually kind of a decent compromise for that. So the joint terminology is now only maintained in one place, and then this group worries about how to get it for the database, and this group worries about how to get it into the deeper representation. Is that particular project the paradigm to follow? I don't know, but more and more people are starting to think about this idea, scalable bottom-end complex reasoner in a hybrid or heterogeneous kind of setup. And of course, take that to the next step, you start getting into sort of an ecosystem of these things, different kind of reasoners, different kind of data. You can imagine, in the intelligence context, I used the example of there's a big difference between saying, find me all the caves in Pakistan and tell me where Osama bin Laden is hiding. Mm-hmm. But if you give the Osama bin Laden is hiding reasoner all of the caves, it's actually pretty complicated. All of the domain model, it has to spend a lot of its time going, this isn't a cave, this isn't a cave. This. So again, you can imagine these systems in a heterogeneous way being able to do very different things if we can figure out how to harness it. I know at least 4 or 5 different doctoral students at different places starting to think very heavily about, what are the models where this incomplete fast stuff and this very complete slow stuff can be linked up. And that's actually my last slide, modular one more. I'll tell you in a minute. So this is, just to summarize, this lightweight ontologies near data is a growing part of the semantic web. Grounding in the URIs is very critical. We're seeing RDF and OWL really being used. In a sense, the semantic web today is about the same scale as the 92, 93 web was, which, to put it another way, means it's almost big enough to be visible on the web of today. A few years ago, there was a presentation on this stuff, and one of the people was from a large search engine and said, there's only a couple million pages with that stuff on it. We can't even, we don't even see it, right? Well, now there's tens of millions of pages with this stuff on, and they do see it. They don't see a lot of it. They're not tailoring their stuff for it, but some companies which have looked in that space, like PowerSet, are, have gotten other people excited, things like that. So a lot going on. And finally, I'm just going to leave this slide up while I take questions. Beyond the semantic web, the other thing that I sort of spend my time doing is we're actually thinking a lot about the fact that this web thing has become very important to the world. In computer science, we kind of, for many years, have treated the web as this application that sits on, it sits on top of the important 7-layer stack of the internet. And it's not, it's just, your browser and some other browsers and no big deal. Right? As it's becoming more and more of a society-changing thing, more and more people are starting to say, hey, weird little changes on this thing can cause real financial damage to people, can cause security issues. Pakistan tried to shut down some YouTube stuff, accidentally shut off the entire YouTube site. Right? Who's suing who over that? Well, no one, because you can't sue a country for shutting down your site. But YouTube lost a lot of money in that deal. Turns out the reason, again, whether it was on purpose or accident is still debated, was because the DNS system was based on an assumption that everybody was trustworthy and happy and sharing in a friendly way, and that if somebody turned off something, it would only do it for their own stuff, and no one actually really thought about if they accidentally wrote it into the ones that would get propagated. Okay, so again, we built this thing in the small. It's gone into huge. And that huge has a lot of social impact. So there's an article about that in the July CACM, if anyone wants to do it. We're really interested in trying to think about, how do we really study this web thing in a scientific way, the modeling, the engineering, and the social impacts. Thank you.
Thank you. There is plenty of time for questions, and please take advantage of, we have Jim here with us. Can you repeat the question?
Sure.
So in the semantic web layer cake, above the O layer, there's the rule layer about having a rule language that builds on top of the ontology language. And I know at least about the rule interchange format efforts, and there is Sparkle as a query language. So how do you see these efforts? Is it actually necessary to have a rule language on top of ontology?
So actually, I I took out the slide that was the new layer cake diagram. So the question was, sort of there's some rule stuff happening. There's the Sparkle data query stuff happening. Does all this need to happen? You didn't even ask about RDFA, which is a way of embedding RDF into standard web text. Griddle, which is a different way. So, I mean, like web services, right? There was SOAP, and now there's an entire stack. There was RDF, and now there's an entire semantic web stack. And the question he asked is, given an ontology thing, do we also need this rule thing? There's no easy answer to that. The ontology world has focused on a particular set of expressivity for the reasons of decidability and stuff. The rule world is looking at other things. The intersection doesn't turn out to be very powerful. So there's sort of two different subsets of first-order logic with very different performative things. And again, it's these damn webbies don't understand this stuff. They just want to use all of it. So they've sort of said, well, make it work together. Same thing with Sparkle. Sparkle is just a way of, right now, is just an RDF query language. But if that RDF query language, so I go to so here's a bunch of FOAF data. That FOAF data includes a lot of information that a reasoner could use to tell whether people are the same or not. So two people with the same email address should be treated as if they're the same person. Okay. Now, I do a query against the thing. It'd be nice if I can ask, by the way, have you applied the FOAF stuff so that I don't have to do the reasoning later? I'll ask you a very different query if I know the answer to that's yes or no. We don't have any protocols for that or anything right now. So there's a lot of interest right now in how we put all this stuff together. What's starting to look like a sweet spot sort of for the next generation of things, again, this is, sort of a researcher making a prediction, so, cover your ears and go screaming the other direction. But it's looking like a big group is trying to make OWL powerful enough so that the rules guys won't be needed, right? There's another group who are saying, maybe the right thing to do is just get a small piece of OWL that we can express as rules or reasoners, but then build sort of a rule language use the rule language on top of that. So there was a lot of problem with rule languages for doing data stuff, just because, again, there's all the mapping and things. So now we use that RDF layer sort of as an intermediary layer, the vocabulary stuff, to get the persistent URIs and the rules to hook them together, right? And again, the problem is if you build big rule systems with thousands of rules and things like that, very hard to maintain, very hard to model. It's why Prolog isn't the primary programming language today that many people thought it would be someday. It's just, very hard to maintain some of these things. But small rule sets, small ontologies, big data, again, another thing people are starting to look at. So, the answer is, do you need all of it? Depends what you're doing. Are there ways to morph one into the other? Yes, just like there's always ways to morph anything in computing into almost anything else in computing. But each of them has certain natural advantages and disadvantages. And so if you can find the right place in the trade-off space to put this stuff, and this stuff together right, sometimes you can get a much larger scale for a much smaller cost. And so again, I think it's more that people are exploring all of these things. But all of these things that come into the standards group have to be at a certain level of maturity where people are saying, okay, we actually want interoperability now. And so I think that's the new thing in the rules language, which 10 years ago was the new thing in the ontology space, was people realizing the importance of that interoperability across applications. So that's kind of my spin on it, and you answer the question how that does necessity and stuff. Yeah.
Could you comment a little about semantic web services, if you see a potential for growth in Web 2.0?
Thanks. That's almost every time I give this talk now, somebody asks this question. I keep saying, oh, I got to put a slide in, and then I keep forgetting. So the question was, could I comment a little bit on semantic web services, potential growth, what's happening in that space? I will, but start from the fact that if you said that about just web services, right? Different communities have different meanings. Do you mean exactly what's happening in WSDL and BIPL and stuff like that, or do you mean things on the web that can do stuff? If we focus more on the technical end of services, the
OS, let's say WSDL.
Yeah, right. So again, so at the technical end of service languages, service descriptors, things like that. So one of the things that actually the DARPA program started funding was the notion that if you actually look at a lot of the SOA stuff, one of the problems you have is matching inputs to outputs only really works right if people did semantic stuff in the naming, right? So I say the output is a number and it's a foofle, and this one has an input that's a number and it's a gloffle. You have no idea whether those two services can be mapped together or not. On the other hand, if I said foofle and foofle, then it works well. Well, you're back to these same kind of vocabulary story we were just talking about in data. So a lot of people started saying, can we take these service descriptors, tie them into these ontologies? There were a lot of research efforts, some of them all the way down to, why don't we just do why do we do anything procedurally, right? We all know logic is better. Let's do the service definitions all the way down to logic. And like a lot of things, that has people who say it's the right thing, but it hasn't really gained a lot of visibility. The thing that has been starting to happen, and in fact there's even some standardization in the space, is being able to take WSDL and say, here's a hook into some other naming space, right, which will tell you more about my input and output and my IOPS, input-output precondition effects. So I'm able to say, if you use this particular attachment in your WSDL, then I can say this thing here, if you want to see more about it, dereference this URI, and you'll find an OWL page or you'll see something else. And at that, you can, see some terminology stuff that may be useful. That's starting to be explored a lot. It really was it's one of those funny cases where there was a lot of money in it in the research world, which was keeping industry from getting very interested. Now that money is starting to cut back a little, so people are saying, hey, show us real use. So there's still a lot of it's still very early days for that stuff. The other thing is the service. So sort of by 2008, everything was going to be in SOAP and WSDL, and every organization would have all of its services advertised and open, and that hasn't happened for a lot of reasons. That has happened much more within the enterprise. Within the enterprise, of course, you can do vocabulary control things that don't necessarily need this stuff. So again, it hasn't really happened at the open scale stuff yet, but people are still really looking at that. There's still a lot of applications that want to go in that direction. So there's still a lot of people betting that that's going to be a very important technology. I certainly keep a research foot in that area. We did a lot of work on, using AI planning systems to compose services, and you desperately needed some kind of semantic. Every time we tried to go just down to the raw services and just use their input-output descriptors, it failed miserably. So yeah, I'd say a promising young. All of this is sort of young, but maturing. That one is sort of a few years behind, but gaining a lot of interest. DARPA looks like it may actually be considering starting a program in it, which will have mixed benefit. But if you're a researcher in the U.S., it's a great. It'll make you very happy if you do this stuff. Eddie. Yeah.
How do you see the academic programs ramping up, or where's the momentum there for this?
It's a good question. So the question was, how do I see the academic programs going in this space? I think it's, again, because more of the funding was in the EU, if you go to almost any EU university that had an AI group, they now have semantic web courses, some of which are formal OWL courses, some of which are actually more RDF and OWL and building web app courses. So there's a mix there. In the States, it's starting to catch on. You're starting to see more of it. You're actually seeing a large demand for training courses now, because again, there's this Web 3.0 stuff. Companies want to hire people. There's a very small number of people who know how to do this stuff. A lot of self-trained people doing very well in it. So small consulting companies are springing up every day because, NASA needs someone to help them do this, and this library needs someone to do this, and then they having done that, they now have 6 people on salary, so they got to find another. So sort of the thing that caused the contractor community in the database world is sort of happening again here to some degree. And the universities are starting to do it. I don't think there's been a couple of books out one of which is sort of textbooky, but again, really the formal language. I have a book with someone else called Semantic Web for the Working Ontologist, which was sort of an effort to not go to the classroom, but to sort of get it in front of the people who are actually trying to do this stuff. There's not really a good answer to that except to say things are happening. What is interesting is this web science stuff, under that name and other names, is starting to get some attention as a thing to have curriculum around, because again, a company that wants to build web stuff needs people to understand it. So, most computer science students, even if they've seen parallelism, have never learned in any course they took in through their PhD how you do the scheduling in a million server farm at a search engine company. What are the things that, you don't just go in with some kind of round robin. Most people don't realize that Google.com isn't, some single big computer back there that's just, got a bunch of static web pages it delivers to you, right? It's a million computers doing a complex calculation using an incredibly complicated scheduling algorithm to get the queries to the right places quickly, that kind of thing. So again, there's a lot of scaling stuff that people are getting interested in the web, and the problem is it's sort of hard to teach that stuff without first teaching HTTP and HTML, and not so much HTML, but HTTP, some of these languages, some of these techniques. So I think we're seeing a growth in the web as a thing to be studied in computer science, and then the next step beyond that is sort of this part of the web thing coming in. So I'm actually very encouraged by that. One of the things that caused me to move from Maryland to RPI is Maryland sort of was reluctantly letting me teach the most popular classes in the department, and RPI wants me to create a whole curriculum with a bunch of people to make this sort of stuff so that our students will be, they realize that people are going to these companies and then being trained about the web. If they came out with training about the web, they'd be ahead of, they'd be able to get some of the jobs that right now are going only to, a few top schools. So I think there's some excitement there, and we're seeing that at other places too. So I think, an open question, but like anything else in the technology space, as it becomes popular, the courses tend to follow, not the other way around.
So following up a little bit on what's happening in Europe, so the semantic web has been a lot of funding in Europe and for quite a few years. Education programs, do you see that translating into businesses there? Apart from businesses which are global and...
No, it's a great question. Her question is, so a lot of money went into Europe, a lot of research money, and in fact Europe actually tends to fund people jointly, companies and businesses and these networks. Are we seeing a lot of business development there? The answer is actually, strangely enough, we're seeing a lot of the business development in Silicon Valley because that's where the venture capital is if you want to build a Web 3.0 company. So in fact, DERI is DERI is a institute in Ireland, has 125 people working for it in semantic web things, very close relationship with Oracle there. They now have started a Silicon Valley group to manage 2 or 3 spin-offs they're creating because it was because that's the place to do it. So one of the things is so in fact the funding world is very weird. It turns out, having lived in this for a while, I actually realized the US tends to fund research and get out as soon as companies express interest. The EU tends to try to fund across the gap. So they come in a little later, they leave a little later, right? In this semantic web stuff, part of what happened is the US view was that the companies are just going to take it over and run with it now, not really understanding the difference between sort of the small parts of it that were ready for prime time and the parts that still need research. Because this is, like database technology, right? We haven't said now that Oracle exists, all the universities don't have database research anymore, but yet that was the thinking in the semantic web, and of course it didn't work very well. In Europe, it was just the other problem. They feel like they've funded it too long, and the companies are coming over here to start. There are some notable exceptions. The UK has several large startups in this, Garlic being the biggest. There are a lot of, so one in the US would be either a center or an institute in a university, will often become a small company in the EU, because then they become a network partner for the university to go after some of these larger grants. A lot of those are now trying to stand on their own feet and become startups in this space. So the answer is there's a lot happening. At the moment, I'd say, interestingly enough, the Web 3.0 stuff is still primarily US. The formal semantic web stuff is still primarily Europe, but a large switch happening at the moment of a bunch of the Europeans realizing that and starting to look at scaling issues, things like that. The other thing interesting is DARPA is starting to fund some what are called seedlings, so pre-programs in quote, Web 3.0. In fact, it was interesting. I was asked to come to DARPA, talk to them about Web 3.0, as I mentioned, and I sort of had to say, well, let me show you the slides I presented when I was a DARPA program manager. Right? You funded this stuff. You just sort of forgot it for a couple of years. This is the path. So I think it's an open and interesting issue. But I think right now, if you're a researcher at a university and want to have semantic web funding, you're better off moving to Europe still. The other thing that was interesting is in the most recent framework, they took semantic web off the list of topics that you could be directly funded for. So they were just tired of people saying, we will build a better way to do ontologies, we will build an ontology assessment tool, and so, but put semantic web into one of the desirable features of the applications they would fund. So there's just been a new funding round, big projects in things like cultural websites using semantic web. And one of the really interesting ones is a big joint project between BBC and a group in the Netherlands. If you've ever gone to one of these sports websites, you can get all the information about every pitch in a baseball game in some kind of database. But if you want to do, merge that with other thing, you're back to the old mashup thing. Some people have been using RDF as the way to do that. BBC is very excited about that. So for the 2012 Olympics, they're going to be teamed with this Netherlands group and try to build website, stuff where not only can you go to their website, but you can have Sparkle access to virtually every minute of every event over the course of the thing with links back to the video. A lot of it with embedded video and stuff. I don't know enough about the actual project. I just heard about a 10-minute talk on it recently. Yeah.
I was going to ask you what you mean. What does it mean to have Sparkle access to? Not anybody can sit down and write a Sparkle query.
Well, not anybody can. Well, that's right. That's right. Well, and hardly anybody can sit down and write a SQL query by at least by the same big O notation. But the key is that the web app developers are starting to know how to write Sparkle access. So the idea is not to make it so that you as an individual can go to the website and pull the luge minute-by-minute thing, but that a third-party developer can use that information to create a luge mashup for the luge community or something like that. So the idea is that they now can become a service provider. And there's some interest in the BBC because you can obviously see how eventually that could be funded through advertising, through joint deals, et cetera, et cetera. Although for this one, since it's mostly government funded, the plan is to release all that stuff free as a proof of concept.
So we'll have to cut now because some people need to go. One person. Thank you very, very much.